As you can see here, the charge and its properties. In this class, I will discuss about the charge alone. The problems related to the charge in another class can explain. So generally, all the materials electrically neutral they are, because every atom consists equal number of positive protons and equal number of electrons, equal number of charges. So it is electrically neutral. So charge is the positive or negative only. So we'll get the charge by, means the bodies become charged by three ways. One is conduction method, another one induction, third one friction. This is the order I have trying to explain. I have given here. So this process is called electrification. By the electrification process, you can make bodies or charged bodies. Now, if we see from any body, you remove the electrons, it becomes a positive charge. Means positive charges will become more. For example, so this is one atom having equal number of electrons and the protons. Initially, it is electrically neutral. So if this electron is removed, so number of positives more. So it behave like a positive. Similarly, if we add any one electron to this body, so number of electrons are more. So it behave like a negative charge body. So after adding the electrons, behave like a negative charge, and removing the electrons, behave like a positive charge. So electrons, we know already electrons have negative charge, protons have positive charge, and neutrons is not having any charge. So coming into properties of charge, so here I mentioned 8 properties of charges. And this is simple property. Same charged particles will attract. Same charged particles or bodies will attract. Opposite charges attract, same charge repulse. So next property, charge is transferable. That means charge can be transferred from one body to another body. In this process, total charge will transfer or not. So in the conduction process, total charge will not transfer. The transferred charge means from the charged body, uncharged body getting some charge by means of charge electrification. So this charge will be less than the initial charge. And in the conduction process, if charging body is having the positive charge, the similar charge is getting by the uncharged body. So vice versa. But in some exceptional cases, so here I have given example. The body is means charged body. Charged body enclosed by a conductor, or the charged body connected by a connecting wire with uncharged body. So there is a possibility to transfer full charge. So coming into next property, charge associated with mass. So if there is no mass, no charge. But if there is no charge, mass exists. Charge cannot exist with mass, without mass. Mass can exist without charge. So if you see here, proton and neutrino have no charge and no mass inside the nucleus. Whereas neutron is having no charge but has mass equal to mass of proton. Means charge cannot exist without mass, but mass can exist without charge. So mass of electron is 9.1 into 10 to the power of minus 31 kgs. In physics problems, we use kgs only. So whereas in AMUs, mass of electron in AMU is equal to 0.00055 AMUs, and mass of proton is equal to 0.001875 something AMUs, atomic mass units. Mass of proton is greater than mass of electron in terms of 1837 times. Means from here you can tell mass of proton is more than mass of electron. Coming to another property, charge is quantized. That means Q is equal to plus or minus M. The charge of the body is by transferring the integral multiples of electrons, not half of the electron or 2 by 3 types of electrons. Like means to get 1 coulomb of charge, we require this many number of electrons. But whereas when proton and neutron compose in a nucleus, not in the free state nucleus, the quarks subatomic particles will form. So those are having this type of charge, this ratio of charges. But in the free state, charge cannot be never in this form. It will be integral multiple only. Means integral multiple of charge of electron, and the charge of electron is smallest charge in the universe. That is, SLBs are given by Millikan oil drop experiment. So next property of charge is conserved, conservation of charge. In charge neither be created nor be destroyed. It transfer into positive or negative charge or another form of charge. This other form means either 0 or positive or negative. So here see initial charge is 0. For gamma particles, no charge. So that will be emitted to nucleus, bombarded with nucleus. So electrons and protons are emitted. So equal number of electrons and equal number of protons are emitted. Similarly, here also electron and proton are bombarded. Some energy is emitted. So no charge. So charge is conserved. So another property, charge is invariant. This means charge is independent on reference. That means speed of the particle. So electron can move with more velocity, and proton will move less velocity because their mass is different. Mass and velocity are inversely proportional, we know. But mass depends on velocity. More mass, less velocity. Lesser mass, more velocity. So inversely proportional. But charge is independent of speed. So next methods of. So this is induction method, not conduction. So in induction process, uncharged body gains the negative charge, means opposite charge. For example, induced charge is equal to, for metals, it is opposite charge. Either equal or less, it is never be greater than Q dash. Q dash is initial charge of the body and Q is induced charge. Q is initial charge and Q dash is induced charge. For metals, K is infinity. So if you substitute here K is infinity, you will get minus Q. Q dash is equal to minus Q. That means the charge is opposite to the charging body. So this is induction process. In induction process, no need of physical contact, and induction leads to attraction. Induction leads to attraction. Initially, the charging in the induction process by repelling the charges. That means if you are taking the positive charge is here. So here another uncharged body is there. So here positives are repelled this side and negatives will come this. So it become a negative charge. By repelling the charge, opposite charge induced or uncharged body. So coming into next method of charging, friction. In the friction, two bodies are rubbing. So in this process, so which one is positive and which one is negative? To find out, so there is a gold leaf experiment actually. Gold leaf experiment. The diagrams and all here I am not giving. So here you can see one order, one clue CFG, CSAAA, RASA have given. That means here the positive nature is decreasing downwards. Negative nature increasing downwards. That means, so here one glass rod and silk cloth we are taking example and rubbing. So glass rod and silk cloth, when you are rubbing by friction method, the glass rod become positive and the silk cloth become negative. So similarly, silk cloth and ebonite rod become negative and the silk cloth will become positive. This is the way of finding the which one is in friction method, which one is positive and which one is negative. They are getting positive charge and negative charge. One is losing electrons in rubbing, depends on their surface and nature and everything. So one will gain the electrons, which is gained and which one is lost. To know, we are using this order of charging. So this is about charging and its nature and methods of charging. So tomorrow, how the charge will be induced and how much it will be calculated, how in factors depends, I'll discuss in next class. Wait for next class.